Okay, so now that you have completed your guided inquiry worksheet, you should be more familiar with the relative basicities between the amine groups and the amide groups as well. So let me just do a brief recap of the key concepts. So for the amines, they are weak bases, and any factor that increases the electron density on the nitrogen atom will increase the amine's basicity because the lone pair is more available for donation. And any factor that stabilizes the conjugate acid formed will also increase the amine's basicity because it will actually favor the forward reaction. This can be found on page 88 of your lecture notes. So in gaseous phase, the stronger base would be your tertiary amine because there are more alkyl groups that are electron donating attached to your nitrogen atom, increasing the electron density on the nitrogen atom, and therefore the lone pair of electrons are more available to now accept a proton. Okay, so the whole sequence would be from tertiary to secondary to primary and lastly to ammonia. This is in gaseous phase. However, in aqueous phase, the order is slightly different because now in the aqueous phase, we have to take note of the solvation as there's a solvent involved. So the tertiary amine is no longer the most basic one. In fact, it is actually not as basic as the primary amine. This is because the conjugate acid of the tertiary amine is not as effectively solvated by the surrounding water molecules. The bulky alkyl groups attached directly to the nitrogen will hinder the donation of its lone pair to form a bond with a proton. Hence, in water, tertiary amines actually ionize to a smaller extent, and they are actually only slightly more basic than an ammonia. Now let's move on to phenylamines. Phenylamines are less basic than ammonia because the lone pair on the nitrogen can actually be delocalized into the benzene ring. This forms a partial double bond which decreases the electron density on the nitrogen atom. Hence, the lone pair of electrons are now less available to accept a proton. The basicity of substituted phenylamines also depend on the nature of the substituent. Hence, if I have an electron donating group attached to the phenylamine, this will increase the electron density in the benzene ring and therefore increase the availability of the lone pair on the nitrogen atom. On the other hand, if I have electron withdrawing groups attached to the phenylamine, this would decrease the electron density on the benzene ring and therefore making the lone pair on the nitrogen atom less available to accept a proton. Now let's move on to amides. Amides are derivatives of carboxylic acids, which you have already learned in a previous topic. So when I react a carboxylic acid with an amine group, I will actually get an amide functional group. So amides are actually neutral in water because the delocalization of the lone pair of electrons on the nitrogen is delocalized over the C double bond O group. This decreases the electron density on the nitrogen atom and the lone pair of electrons is not available to accept any proton. Now, you can try lecture exercise 3.1 to try and arrange the following in the order of increasing basicity, giving your reasoning.